Good day, ladies and gentlemen. I welcome you all to Shito's Mathematics Coaching Program. Before the commencement of today's lecture, I urge every one of you to kindly subscribe to my YouTube channel. Hit the bell at the subscribe button in order to get the notifications of my video anytime I drop them. As I said earlier, so we are going to start starting on our board. So we have the topic that is the modulus and the conjugate of complex numbers. So now what we'll be looking at is what is called the modulus of a complex number, and at the same time the conjugate of complex numbers. So now let's start. Given a complex number z to be equals to a plus ib, that is the real part and the imaginary part. You can see that that is complex number. So now having this or giving this a complex number z, so now the modulus of this z is denoted by z absolute value. So this modulus we can call modulus, we can call it modulus, we can call it what? Absolute value, and also we can call it what? Magnitude. Yes, magnitude, that is magnitude of what? Magnitude of z. So is that you call it modulus, or you call it absolute value, or you call it what? Magnitude of what? Of z. So the three statements mean the same thing. I mean the three words make the same word, mean the same thing. So the modulus of this is now equals to a squared plus what? Plus b squared. A squared plus b squared. So that's the definition of the modulus or absolute of magnitude of what? Of this complex number z. So this a squared is same thing as what is real part squared. You can see this is the real part, that is this the real square part. I definitely real what? The real part, that's what? A squared. And also b squared means what? The imaginary part. Which means the modulus of a given number is what? Of a complex number is the square root of the sum of the real parts plus and what? And the imaginary part. The square of the imaginary part. So that's what we have here. So now this absolute value of a complex number now give what? Give us real number. You can see, saying this inside the square root, you can see that there's nothing like I imaginary there, which means if you get the absolute value of any given complex number, so what you have is real number. So no longer complex number. So that is that about what? Modulus of what? Of complex number z. So now if you now want to talk about conjugate, that is conjugate of what? Of z. Conjugate of z, that is denoted by what? By or represented by z what? Z bar. So that is what? That is conjugate of what? Of z. Are you getting it now? So that is conjugate of z. So if you have z, the conjugate of z will be a minus ib. Given z, so the conjugate complex of what? The complex conjugate of what? Of this z is I minus b. Are you getting it now? So what did we do? We just changed the what? We just changed the sign to what? Minus. So now let's say we are giving z, that is z minus equals to a minus ib. Are you getting it? So now we now ask you to find the conjugate of it. The conjugate of it will be a plus ib. So which means we just change the sign from minus sign to what? To addition sign. Are you get what I'm saying? So now that is that about what? About conjugate of what? Of sort. At the same time, another thing that we need to know concerning this conjugate of what, of z, of complex number, that is, if you are given any kind of complex number, that is like this z, so now if you multiply this z by its conjugate what, complex, so you have what, you have a perfect what, you have a rational, that is, you have a real number, you have what, you have a real number, you have an exact value, so it will no longer be what, be complex any longer. So that's what I'm trying to say. So now let me give you one example to do. Given example, a perfect what, you have a rational, that is, you have a real number, you have what, you have a real number, you have an exact value, so it will no longer be what, be complex any longer. So that's what I'm trying to say. So now let me give you one example to do. Given example, for instance, given the complex z, that is complex number, that is z equals to 3 plus what, plus I, 3 plus I, so that is that. So now they now ask us to find, they ask us to find z as well as value of z conjugate, and z dot z conjugate. So that is what they ask us to find. So now from here, solution, let's say you have solution here, 1. So now if you want to do this one now, so they said absolute value of z is same thing as the z given to us plus what, plus I, which is equal to the square root of, look at this, what is our a here? A is 3, that is 3 square, and what is what, what is b? B is what, is the coefficient of this, either the coefficient you have it here or at the back of I, so it's what, is 1, so we have 1 square, which is same thing as what, root of what, root of 10, because 3 squared is 9, 1 square is 1, then 9 plus 1 we have what, we have 10. So now we have the second one to be, that is z conjugate, z conjugate. So the z conjugate, that is 3 plus I conjugate, will be automatically 3 minus what, I. Are you getting this? So which means we just change what, we change the sign towards to addition, from addition towards to subtraction. So now the third one is z dot z prime. I'll be back. So the z is 3 plus I multiplied by the z bar is what, 3 minus I. So now from here, so let's say we go for that, we see that we have, multiply this one by this, we have z dot z equals to what, equals to 9, that is 3 times 3, this times and this we have minus 3i, this and this we have plus 3i, then this times this, plus times minus is minus, I times I is I squared. So from there we have 9, minus 3i plus 3i, so it will be 0, minus 1, so we have what, we have root 10. Are you getting it? So that is that. So z dot z bar gives what, we have as what, as 10. So which I said earlier that when you multiply a complex number by its complex conjugate, so you have what, you have real number, which is 10. So 10 is a real number now. So now lastly, note here that z dot z prime or z bar equals to what? Equals to absolute value of z squared. Are you getting it? Absolute value of z squared. That is, this multiplied by this equals what? Absolute value of z what? Of z squared, or modulus of what? Z squared. So now let's prove. You can see from the problem solved here, you can see that z dot z prime give us what? Give us 10 here. I get it. So now from here, that is from 3, that is from what? From 3. So now we can see from 1 we have z equals to what? Root of 10. Are you getting it now? So from what? From 1. So now you want to make this 10 the Sawyer formula, that is, let the 10 be standing alone. So from here you can see that 10 will be equals to what? How is it? Z will be equals to 10. So how did we get what? How did we get this 10? We try to square the both sides of this. That is, square will be here, square will be here. This square, we cancel this. That's why we have this 10, then we have this. You can see that the right hand side of this are the same thing, that is z dot z prime equals to 10, and also absolute value of z squared gives us 10, which means this is equal to this, which we can deduce that z dot z prime z bar equals to z, that is absolute value of what? Of z squared. I get what I'm saying now. So that is how we solve the problem concerning modulus and the conjugate of complex number. So now from the problem that I just solved, if at all you don't have, or maybe you have what they call any question to ask, or there's something you don't understand, so kindly ask me. Hit the comment box and ask any kind of a question, so and I promise you I will give you the best answer to that. So now do not forget to, if you have not done that, so do not forget to at least, understand, click on that subscribe and hit the bell at the subscribe button to get the notification of my videos, so you have a wonderful day. Thanks.